Alright, in this video, let's get started with the meat of our edit mode. We need to jump in here and get the edit screen set up to handle all of the functionality that we're going to need to use. Now, in this video, of course, we're going to break this up over a few videos, since there are quite a few things that need to be covered here inside of edit mode. So we're going to be doing things like setting up the edit mode screen to be able to handle songs, to make sure that the right draw calls get passed off so that we can see the song, see the staff, and be able to work with the song itself. Now, the very first thing that we're going to need to address is going to be the individual input modes for the edit mode. And what I mean by input modes is we're designing the game around a very simple baseline controller. We're saying that we want the Rock Band 1 drum kit to be a usable controller in all elements of the game. Now, we are kind of limited on the number of buttons we have.
Sure.
Since we aren't given full access to all of the buttons normally on an Xbox controller, and some of the buttons that we do have are used up for things like drum input.
Right.
So what we're going to do is inside of edit mode, we've run into a scenario where we have more functionality than we have buttons. What I mean by that is, in the previous video we talked about moving a cursor around the screen to place notes. Now, obviously, you'd want to use things like directional buttons in order to move the cursor.
But a drum kit doesn't have... Well, I mean, it does have directional buttons, but assuming that you didn't ever want to drop the drumsticks, it technically doesn't have them.
Exactly, and we also run into more complex scenarios where, in addition to just adding and removing notes, it would be helpful to be able to seek through a song forwards and backwards very quickly, instead of having to move note by note, grid cell by note, grid cell. So that means we want to be able to very quickly jump back and forth between our directional buttons moving a cursor and our directional buttons moving the whole screen forwards and backwards.
So that would be like two separate modes.
Exactly, and the way we're going to express that here is by allowing edit mode itself to be switched into different input modes.
Now, are there any other modes that we're going to have aside from the ability to seek and move a cursor around to edit notes?
Well, we're going to have a handful. In addition to moving around, we're also going to need the ability to adjust the tempo, adjust the note granularity, and this is going to control the size of our grid cells, and we're going to have a mode that will allow us to shift an entire song.
Okay.
So we can, instead of adding and removing notes one by one, we'll be able to take every note currently in existence and move all of those notes by the current grid snapping.
Very nice.
The reason this is useful is, let's say you had recorded a song in free play mode, and you had waited a few beats before you actually started playing, and now you really liked the result and want to play that in single or multiplayer. Edit mode is going to let you take your whole song and shift it so that the first note really starts at the beginning of the song.
Okay.
So just as a recap, we're going to have our set of modes will be note mode, seek mode, tempo mode, granularity mode, and song shift mode. Now, with all of that in mind, let's turn around and actually drop that down here in code. This idea of modes is first going to be expressed as a simple enumeration. So we'll have an enum, which we will call edit mode. And for a set of edit modes, we'll begin with note. We'll actually call this note edit. So this is the mode where we move the cursor around and drop notes in place. Moving on from here, we have seek. So we can move the entire song, or this is the one where we're describing as moving around the screen. We're going to have tempo to allow us to adjust the BPM setting for any given song. We'll have granularity, which will allow us to adjust the grid snapping, and we're going to be actually setting this in terms of individual note values, meaning a grid setting or a granularity setting may be an 8th note or a 16th note. And finally, we need to have song shift mode. So we'll make a mode called song shift. Alright, now that we've defined that these are the different types of modes that can exist, we're now ready to turn our attention to the the edit screen itself. Now, the first thing we need to do is to drop down a handful of fields that our edit screen is going to need. The first of which is going to be an internal song instance. Just like in the gameplay mode, we as a screen are going to need to hold onto a song because that's going to allow us to hold note data, progress through the song, and allow the song to play, and so forth. So we'll have a song field, and just like we did before, we'll call this field song. Now we also need to, inside of the screen, remember what input mode we're currently in. So we're going to make an edit mode field that we'll call mode. So that way we look around inside of screen and say that, okay, we're in our mode is currently seek, therefore the arrow keys need to do something different. Alright, now we need 2 additional fields, and these are both going to be flags, so we'll set them up as Boolean values. We're going to have a flag that will control whether or not the song is currently playing, so we can drop this down as bool playing. The reason we're going to have a flag for playing is the edit screen is of course going to have the ability to play a song back, so that way you can immediately hear what it is you're editing. But you don't want to edit a song as it's moving, so that really means that the edit mode is going to be able to both pause and play songs.
Okay.
So we're going to hold that state as a simple Boolean flag, and that means whenever this is true, then we'll make sure that game updates get passed along to ticks and we see the song play and move across the screen.
But you won't be able to drop notes.
Exactly. So if you pause the song, we'll just set playing to false. That will tell the screen to stop updating, stop calling the tick method on the song, and the visual effect will be that the song will pause.
Okay.
So then the song will be still, and you can edit as need be. Alright, one more flag that we're going to have will be used in conjunction with saving. We're going to make a Boolean field called changed. And the idea with changed is we'll use this flag to track whether or not something has been changed in the song, thereby indicating that the song needs to be saved.
Okay.
So we'll use this to allow a user to load up a song into edit mode, maybe even play through the song, but as long as they didn't change any of the notes, we won't annoy the user by asking them if they want to save the song. We'll simply track anytime a change occurs, like a note being dropped or removed, then we'll set the changed flag, and then when the user leaves the screen, then we'll know that we should ask them if they want to save their changes. Alright, moving on from here, that takes care of the instance fields for our edit screen. We're going to put a handful of static fields in place as well. The reason that we're going to make these static is we're going to make a set of fields that are useful both inside and outside of the edit screen. These are going to be things that will describe where our cursor, our editing cursor, is currently placed, as well as what the current grid setting is. So we're going to make a handful of fields. All of these fields will be both public and static, and we will make them integer fields. So the first one is going to be an int called edit cursor, and this is just allowing us to record in terms of a tick value where our cursor is currently placed. Now, of course, in order to place a note, we need more than just a tick. We also need to know what track the note's going to be placed on. So we'll make a second public static int called edit track. So this will allow us to give up, down, and left, right coordinates if you look at the way the horizontal renderer is currently set up.
Sure.
Then one last field we'll have, one last public static integer field, is going to be edit granularity. And this is going to describe our snapping value. And from the snapping value is how we derive the actual grid. This is, of course, going to be useful inside of edit mode because we're going to need to know how much to move the edit cursor. And it's going to be useful outside of edit mode because the renderer will need to know exactly how to visually draw the edit grid. Alright, moving on from here, before we get into the screen-based functionality of edit mode, we're going to drop down the skeleton for a set of utility methods. Basically, there's going to be different types of functionality that we're going to need to call on when various actions take place, when notes are dropped in place or when the user moves a cursor around. So we're going to drop all this common functionality down into individual utility methods. So we'll begin with the first of these methods. It will be void return type, and we'll call this move cursor forward. We're not going to take in any parameters, and we'll simply block in an empty method body. All of these utility methods are going to be set up to operate on the internal state, these internal fields of the edit mode, so we're not going to need to worry about passing things into or out of them. Now with move cursor forward, this is a simple way to allow us to move or manipulate the edit cursor. So whenever we go to do a move cursor forward, there is actually there's a few different operations that need to take place. So rather than duplicate these operations across the different input handling code, we're going to group them all together as move cursor forward. So we'll do things like find a new tick value, possibly a snapped tick value, and then we'll make sure that that new value is on screen. So we make sure that we always keep the edit cursor in view. Alright, Moving on from here, we'll have a second utility method, also void return type. This is going to be the opposite of move cursor. This will be move cursor back.
Watch your spelling on cursor.
Ah, yes. Spelling. Always the bane of our existence. And also hitting random buttons. That's also not fun. I'm telling you, that spelling will get you every time.
I'm telling you.
So, there we go. Move cursor back. And this is just the counterpart to move cursor forward. Again, we're going to be doing very similar type functions, probably decrementing a cursor value, resnapping it, and making sure that it's on the screen. All right, now we have another set of utility methods. These will be used to move the entire song, so you can almost say that these would be used in seek mode. As a matter of fact, we're going to call these seek forward. And a second one, we'll just go ahead and drop it down as seek back.
Now, without getting all that kind of, all technical with what's going on inside these methods, their names pretty much tell you what's going to be going on with each one.
Right, we're just going to be moving, advancing into the song or moving back. So just allowing us to seek the cursor position in the current song. All right, one last utility method that we'll create. We'll drop this down again, void return type. This method is going to be called place edit cursor. And the idea with place edit cursor is there's going to be several cases in the edit mode where we'll move something that is going to necessitate the edit cursor to also be moved. For example, if we were in seek mode and we managed to seek a few measures past where we were editing, we want to make sure that we bring the edit cursor with us so that when we stop seeking, we have the edit cursor available. We don't want to have the edit cursor left 5 measures off screen and have to move it on screen.
Okay.
So this is going to be a simple method to make sure that we get the edit cursor placed within the visible viewing area. All right. Now with that skeleton, we're leaving it in place simply as a skeleton so that we can code the meat of edit mode. And we'll code it in such a way that we'll be relying on some of these methods, but we'll come back and code them in as they become relevant to some of the various input systems. Before we address them, we need to handle things like exactly how the edit mode loads up a song and all of the basics of the screen itself. So that means it's now time to move into the methods that the screen edit is going to need. We'll begin with all of the methods that we're going to need to override from screen. You can see we already have process show in place, and we're using that to make sure that we swap over to our edit maps input setting. Now, in addition to process show, there's going to be quite a few other methods that we're going to need to override. So let's drop all of these in place, then we'll begin back from the top and code them all in. So the next step after process show is going to be process hide. We'll need an override to process hide. We'll remove our call to base.process hide. And this is going to be where we'll handle song saving, making sure we get the hold song fields set up and show the save prompt. All right. After process hide, we'll need to do some input handling. So we'll override input pressed. And again, we'll pull out the call to our base.input pressed. Excuse me. And of course, this is going to be where we'll be doing all of our input handling. Our edit mode is also going to need to handle reset. So we'll add an override to reset. And we'll do things like get the current song loaded up and ready to go. After reset, we're also going to need to address update. So we'll have an override for update. And that way we can observe the passage of time and make sure that our song itself advances in time. And then one last method we'll be dealing with is going to be draw. So our final override will be here to the draw method, where we will make sure that we do leave our call to base.draw in place. And that is all the methods that we'll be addressing. Again, we're just getting these laid in here so we can kind of get an idea of where we're going with edit mode. Since a lot of things kind of need to happen all at the same time, we want to be clear as to the fact that, okay, this is like any other screen, this is following a set procedure of the way we'll be handling things. All right, going back up to the top, let's go into process hide and set up the necessary code for getting a song saved out. At this point, we really have all of the saving functionality we need, because, of course, like we saw in free play mode, songs already have the ability to save themselves. And now, at this point, we already have a save prompt screen, so it's just a matter of putting a few things together. So what that means is the moment the edit mode is hidden, we'll do a check, and we'll see if anything has changed in the current song. So all we'll do is we'll check our changed flag, and if there have been changes, then we know that the current song, whatever is held in the song field, needs to be saved out. So that will be accomplished by recording the current song and the current song's file name into our hold song fields, and then showing our save prompt. So we'll look into global state in order to gain access to our hold fields. So we'll set hold song to be equal to this current instance of song. And then we'll again look into global state to grab the hold song file name and make sure that we set that to the current name of the song that was just loaded. Now again, we can't look into the song itself because the song doesn't record a file name, but since edit mode is loaded up as a result of going into the song selection screen, we'll already know what song is selected by simply looking back to the song library. Much like we do inside of the game mode, where the moment the game loads up, it looks back to the song library to get the current selected song.
Right.
So this will be a simple matter of looking at song library dot selection. So with those values now copied over into global state, we're ready to show the save prompt screen. So all we'll do is take screen and make sure we do a call to push screen, and we'll push the screen named save prompt. And from there on out, it's save prompt's responsibility to get the necessary user input and save that out as a file. All right, moving on.
Now, real quick, you've shown us some things with process hide. I know you're not going through these linearly, but are you going to do any changes to process show as well?
Let's see. Looking back over, while we're here, there's probably is a few things to handle. And these are more of just for resetting the state, meaning let's say you had already been inside of edit mode, made some changes, made sure the change flag got set, and then left edit mode. Whenever you come back into edit mode, you want to make sure those get set back to an initial state. So what we'll do is we will do a few things here in process show, and we'll make sure that our change flag gets set back to false, and we'll also make sure that if we changed our actual input mode, we change that back to node editing. So we'll make sure that we look at changed and set that to false. The idea is that upon loading up edit mode, if you've just loaded it up, obviously you haven't changed anything yet, so changed will be false. And we'll also make sure that mode gets set back to a value of edit mode dot node edit. So yes, in that case.
So now we're immediately ready to start changing around our nodes.
Exactly. That way, even if we've already loaded up edit mode one time already, once we reload it, we make sure everything goes back to its initial state.
Gotcha.
All right, moving on from here. There are things we need to address in input, but we'll hold off on those for just a minute. Instead, we'll move down to reset, where we can take a look at getting a song loaded in and ready to go. So inside of reset, we'll do things like, first, making sure that we're not currently playing. When we load up a song for editing, we're going to load the song in a paused state. And we'll represent that here inside of edit mode by setting our playing value to false. Alright, now that we've indicated our current play state, let's also make sure that we reset all of our editing fields, those static fields. Things like edit cursor, edit track, and edit granularity. We'll make sure that upon reset, the edit cursor automatically goes back to 0. We'll make sure that the edit track also gets reset to 0. And we'll set up a default note grid snapping value of 8.
Is that representative of like an eighth note?
Exactly. We're going to set up our notes much like we did when we set up free play mode, and we allowed that recording granularity setting in the config file.
Right.
And we made it so we could set that in terms of actual notes, where 8 would be an eighth note, 32 would be a 32nd note. And we're going to do the exact same thing here with edit granularity. When we say that granularity is set to 8, we are saying that we're snapping to eighth notes. Alright, now let's look at the song itself. Let's get the actual song instance set up and get some song data loaded into it. So we'll look at our song field, and we'll set that to be equal to a new instance of song play, we'll actually be using the same song play class that is used inside of gameplay mode. And this is useful to us here because we can get certain events fired back, like when notes play or when the song ends. And those will be useful to us here inside of edit mode. Alright, now that we've got our song instance, let's turn around and load the currently selected song from the song library into our song instance. So we'll take our song, we'll make sure we fire off a call to load song file. We need to pass in the file name, so we'll look into our song library, and we'll grab the selection out of song library. And again, in any load call, we need to specify how many tracks are allowed to be used, and we're going to specify the current number of tracks that are used in config. So if we look at config.trackNames, the number of names will tell how many tracks we have, so we'll pass in tracknames.count. Alright, now that we've got the song file loaded up, if we were in an earlier game mode, like gameplay mode, we would have at this point generally reset the song. And we'd be calling reset to make sure that the cursor internally inside the song would get set up correctly. Now, in the song reset method, we handle things like lead-in. In edit mode, we actually don't want any form of playback lead-in. There's no point in firing off a 4 count if the first thing you're going to do is jump in and begin deleting notes.
Right.
So what we're going to do is we're not going to use the reset call. Instead, we're going to directly set the cursor. So that means we'll look into song, and we'll say song.setCursor.
There you go.
And we'll pass in a value of 0. So we're just saying that the song will be set to position 0. That gets us ready to either immediately play or just take advantage of the fact that the song is paused and be set and ready to go for editing. Alright, now that the song is set up, we need to make sure that the proper tempo loaded from the song gets applied to the game. So we'll look out to global state, and we'll make sure that we make a call to set tempo, and pass in the current song's BPM, song.bpm, and song.ticks per beat. And then make sure that if we do indeed go in and begin playing our song from edit mode, that we're using the correct tempo when we play the song. Now, 2 more things we need to do here inside of reset, and that is we're interested in a few of the events that the song is going to be firing. The first of those is going to be ended. So if we look at song.ended, and then do plus equals to subscribe a new song handler delegate, and then we'll hit tab again, accept the name song ended, which will drop in a method handler. And let's see, while we're setting up methods, let's also set up a second handler. The other thing we're going to be interested in is song.notePlay. So we'll do the same thing, plus equals, tab to drop in the delegate, tab again to drop in the method, and we have a handler now for notePlay. The ended event is useful to us because when we reach the end of a song that we're playing back and listening to, it'd be nice if the edit mode would automatically stop playing at the end of the song. And note play is going to be useful because that way, since the song play is already set up to note the passage of individual note values, we'll let that get passed on via an event, and that will allow us to play the appropriate sound for each note as it's being played. So very simply, we'll be able to gain actual song playback. Now inside of these handlers, we do need to drop a little bit of code in place. Inside of note play, all we're going to do is play the appropriate sound. So we'll look into global state, we'll look at our sound engine and tell it to play a specific sound. For the sound index, we'll pass in note.track. And then that's all we should have to look at for song playback. Now, in order to handle the song ended event, we'll need to do 2 things. The moment a song ends, we'll flip the playing flag back to false. That will cause the song to pause. And we'll also need to make sure we address the edit cursor. So let's drop some of this in place. We'll need to look at this.playing, our playing field, and make sure it gets set back to false. Now, in this case, when a song ends, generally the song will have moved a great deal, meaning we'll have seen a lot of measures go by, and then the song will finally stop at the end. Now, if the user wanted to begin editing at the end of the song, we'll also, as a convenience, drop the edit cursor on screen to make sure that it's in view in case the user wishes to immediately begin editing.
Gotcha.
Now, earlier we made the utility method called placeEditCursor, so we'll simply call upon that. That way, anything that needs to happen in order to get the cursor moved in place will be handled inside of there. Alright, moving on, we can now take a look at update. Update will be very simple in this case, since all we're doing is passing along calls to song.tick. We do need to do a check where we make sure that we're playing before we pass those calls along. So we'll say if this dot playing, then we'll pass on calls to song.tick. And this is really where our pause mechanism comes in. Is normally just calling song.tick would cause the song to continue playing. We make sure that if we set playing to false, we simply avoid calling tick, and that's what causes our song to stop playing.
Which means that playing is not necessarily an indicator. It's actually the switch which is turning your song on and off.
Exactly. Alright, one last method to look at here, and that is the draw method. Instead of draw, we need to do two things. We need to make sure that the current renderer, the current active renderer, is told to draw our song instance, and we're also going to draw some information to the screen. Much like we did in gameplay mode, we were drawing the current tempo as BPM. Here in edit mode, we're going to draw the tempo, and we're also going to draw the current snapping setting as well as the input mode. But beginning first with the renderer, what we'll do is we'll look into renderer, we'll grab the active renderer, and we'll tell that renderer to draw. We need to pass in the current sprite batch, and we'll also pass in this dot song. So we'll be using the current renderer to draw our song instance here inside of edit mode. Alright, now for the informational text, all we'll do is we'll put together a string using some string formatting, and then turn around and draw that to the screen using the current tempo position. So we'll make a string called text, and we'll assemble this text using string.format, where we need to put together a format string. We'll say the first thing as part of the string is going to be the tempo, so we'll drop in BPM, and we'll specify that as argument 0. Now we'll put a little bit of spacing in place. Here I'm going to put about 3 spaces in between that, and then we'll drop in our current granularity, our note snapping. We'll actually call this value note step. And again, if you so choose, this could be any number of things. This could be note snapping, note value, note granularity. We're just going to call it note step here. And we'll specify this as argument 1. Move 3 more spaces over, and we're going to draw the currently active input mode. We'll actually draw this inside of square braces, so we'll drop square braces, then drop in our curly brace for argument 2. That takes care of our format string. Now we need to feed in the various values that will fill out those arguments. Argument 0 is going to be the current song BPM. Argument 2 is going to be our current edit granularity, and the final argument is going to be our current mode. So that should assemble all of that information into a single string, which we can draw using spritebatch.drawString. We need to pass in a font, so we'll use the small font. We'll look into style and grab font small. Then when we go to draw the text, we'll draw this out as the text variable. We need a position for our text, so we will reach into style positions and grab BPM. Finally, we need a color, so we'll look at style colors and drop in text BPM. And that should take care of showing all of the information we may need to be aware of as we work here inside of edit mode.
Cool.
Now, before we address input, since we've already at this point dropped down quite a bit of code, let's build the game and see what we're looking at so far. Because reviewing the functionality, we have put reset in place, we are loading up a song, and then later in draw we are updating that song.
So we should be able to see something.
So let's jump into the game, go down here to Song Editor, we'll go ahead and select 2x bass as our song, And look at that.
Wow.
We have a screen that looks very much like gameplay mode. We have our full graphical staff drawn. We have information here at the top of the screen saying that this song has a tempo of 180, which is correct for the current song. We're currently using eighth notes to snap, and we are in note edit mode.
Mm-hmm.
Now again, at this point, since we haven't addressed input, we can't move around, we can't even exit out of the screen.
Right.
But this is showing that we have a song in place, and one key difference from edit mode to playback mode is we are indeed in paused state. We've set our playing to false initially, and that means rather than jumping in and seeing the song move, we do see a paused song ready for editing. So with that now, it's time to look at some input code. So back here inside of Screen Edit, let's jump all the way back to the top with input pressed. And let's see, since we're going to be needing to look at buttons quite a bit, we're going to grab the current named input out of input data and store that as a local variable. So we'll make a named inputs variable called named input, and that will be equal to input data, dot named input. Again, just copying it for convenience sake. Now, here inside of input press, there's actually going to be quite a few things we'll need to deal with. So we're going to be separating things out into different sections. The first section is going to be a set of inputs that apply to all modes, meaning regardless of whether we're in note edit or whether we're in seek, there's going to be a set of buttons that always do the same thing. These will be things like the back button, meaning no matter what mode we're in, we can still exit out of edit mode, and things like the select and reset buttons. So first, let's look at back. Matter of fact, the very first thing we'll do is we'll drop down a comment so we can start dividing this into sections. We'll say that these inputs will be applied to all modes. Alright, the first of which is going to be the back button. So we'll create an if statement that says if named input is equal to named inputs.back. Then all we're going to do is pop the current screen. Screen.popScreen. And then that'll take care of removing edit mode and moving back to whatever screen came before it. Alright, let's also drop in the input for select. So we'll put in an else if statement, else if input data, or excuse me, named input, is equal to named inputs.select. Now select is the button that we're going to designate as our mode switching button. So that means if you were using a keyboard, that would mean hitting the enter button is going to let you advance from note edit to seek to granularity and so on.
Mm-hmm.
Now, the way we're going to advance to a different mode is we're going to leverage the fact that we can look at each of our values in the enumeration as a numerical value.
Okay.
And since we didn't explicitly specify these, we could say that note edit is going to be starting out at 0, 1, 2, 3, and 4. So these are all going to be 0-based in their default behavior. So what that means is if we were on note edit and we wanted to advance forward to the next mode, we could simply take the numerical value 0
and increment it
to 1, and then we'd be looking at seek. So we're going to do exactly that here inside of our input. So as soon as we hit select, we'll take mode and simply increment it. Just treat it like a number. Now it gets interesting when we need to wrap back around. Of course, once we reach the last mode, if we look at the last one here as song shift, we want to wrap back around to note edit.
Mm-hmm.
Now in this case, there's two ways we could go about doing this. We could do a very simple if statement, and we could say if our current mode is song shift, then set it back to edit. Now since we had already started looking at this as a numerical value, let's actually see what we would need to do to numerically note the fact that we've walked off the end of the enumeration and loop back around to the beginning.
All right.
In order to do that, we'll need to be able to look at how many elements we have inside of the enumeration. And since looking at an enum, of course, we can't do something like .count, since the enumeration is a type, it's not an actual instance. So rather than going through and looking at, like we would do in an array and a list, and looking at a count, instead what we'll do is since we have already advanced mode, we'll then do a check and make sure that that number is still valid. Meaning, if we walked off the end here of 0, 1, 2, 3, and 4, that meant if edit mode was given a value of 5, it would no longer be defined here inside of this enumeration.
Gotcha.
So
we'll just simply check to see if the number is defined, and if it's not, we'll wrap back around?
Exactly. So that means as soon as we advance, we'll now look at our enum. The enum type has some functionality built into it, and that we can look at that by seeing enum. And then out of all of the things that we can do, what we're interested in is the fact that enum itself can run an isDefined on a specific value for a given enumeration type and tell you if that is an allowable value inside of the enumeration. So what we can do is say if enum.isDefined, now we need to feed in the type of an enumeration. So we'll use type of to retrieve the type of our edit mode enumeration. So we'll pass in type of edit mode, and then we'll pass in the value that we want to check, which is going to be mode. And that's going to return true if this mode was currently in this enumeration. Now what we're interested is in if this mode just became invalid. So what we'll do is we'll say if not enum.isDefined for that mode, then we know that we've walked out of the end of the enumeration and we need to reset ourselves. So generally this would be as simple as mode equals edit mode.noteEdit. But again, since we're treating everything as numeric here, we'll specify the numerical value 0. Now 0 itself will need to be looked at here as the number, but again, since we can look at this in terms of a number, just like when we were incrementing, we'll just reset to 0.
Mm-hmm.
Now, since there's been a lot of interesting number manipulation, let's jump in at this point and make sure that everything is working. So if we jump into our song editor, load up our first song, if we hit enter now, so hitting the select button, we can see we go from note edit over to seek, over to tempo, to granularity, to song shift, and then here's the moment of truth. If we hit select again, we wrap back around to note edit.
Very nice.
So again, if this could all be simplified to just setting the values based on our enumeration, but one of the advantages to using everything in a numeric manner is what would happen if we were to add a new arbitrary edit mode. The whole point of doing all of that exercise with numbers is to make sure that our selection code is adaptable. For example, if we added a new edit mode called cat, our code will now adapt to the fact that that element exists. So now as we go through getting down to song shift, last time we wrapped back around to note edit, but here we take cat into account automatically.
Gotcha.
And then we wrap back around to note edit.
So if you came up with some new kind of mode, like maybe you write a system that allows you to select an entire block of notes and copy it off so you could paste it over and over again, that might have its own special mode.
Exactly. And the code for selecting modes is now adaptable. So you're free to drop in your new, you could say your block copy mode, and put that here inside of edit mode. Alright. There's one last thing that we need to address for our input code for this video, and that is being able to play and pause our song. The way we'll handle playback is we'll use the reset button, so spacebar on the keyboard, and we'll use that to either play or pause the current song. So let's drop down the input code itself. That's our else if. That's going to look at our named input being equal to named inputs dot reset, and that gets our button detection in place. Now what we need to do when the reset button is placed is first check the playing value and basically reverse that value. So if we are playing, then we'll pause the song. If we're not playing, then we'll play the song. So we can do that with a simple if statement. First we'll check playing. We'll say that if we are not currently playing, then we need to begin playing. Now before we actually begin playing, we're also going to do a simple error check and make sure that there are notes to play before we begin playing. So we're going to check not only that we're not currently playing, but we're also going to make sure that song.notes.count is greater than 0. Now generally this should be greater than 0 since we have to select a song to get it into edit mode in the first place. But again, this is just some checking in case someone managed to make a blank song file and we're trying to load that into edit mode. So we'll make sure that if we're not currently playing and we do have notes to play, then we'll check our playing value and set it to true. So in that case we would begin playing. Now if we were already playing, then we'll put together an else clause to handle. So basically, if we were playing, we need to take our playing value and set that to false. and this will simply stop the current playback.
Okay.
Now, in addition to just stopping, since again playing is going to cause us to move throughout the song, we will also drop the edit cursor on screen the moment we stop playing. And that means we just need to make a call to place edit cursor. So, with this in place, let's see what we get so far. Let's jump in, load up our familiar 2x bass song. Again, we load into a paused state, but if we hit the spacebar, and then hit the spacebar again, we can both play and pause the song.
Very nice.
So we can now start and stop playback at will. And then one last thing we need to check is to make sure that our proper event handling occurs at the end of the song. So I'll go back into playback and let the song play to its end. And you can see that the song playback does stop at the end of the song. Now there's one last thing we need to address. Now that we've hit the end of the song, if we try to hit the spacebar again to play, you'll note that nothing happens.
Yeah.
And what's happening here is we are setting the play flag back to true, but the moment we do, and then the moment we update the song notes that it is still at the ended position.
So it stops.
So it doesn't go any further forward and just fires off and reminds us the fact that the song has ended. And then, like you said, that results in stopping. So what we need to do is, if we're already at the end of the song, we want to make sure that we reset and play from the beginning of the song. So we'll do that by looking at the position of the last note. And if our current cursor position is past the end of the song, then we'll restart from the beginning of the song. Now, in order to see where that note is, we need to grab a specific note. We'll do that by making a local variable called last note, and we'll set that to be equal to song.notes, and then we need to grab the very last note out of the notes list. And we can do that by looking at how many notes we have, song.notes.count,
-1.
and then -1 to address a valid note.
Right, because it's 0-based.
So that will give us the last note of the song. So then we'll do a simple check and say if song.cursor is greater than or equal to last note.tick. That means we are on or past.
Put last note.track.
And that would be important too, because having only 8 ticks worth of space would not be very helpful. So there we go. Very good. Note.tick. So that way, say if the cursor has gone past the last note, then we will take our song and we will run a set cursor to position the cursor back to a value of 0.
So basically, if we're at the end of the song and we tap the spacebar again, it should just start over?
Exactly.
Cool.
So let's test and verify that. Back into Song Editor, load up a song, we'll let the song play all the way to the end. And the song playback does indeed still stop. If we hit spacebar again, we begin back at the beginning of the song.
Now what if you pause in the middle and start over?
Well, we're going to keep playing.
Nice.
So we've still retained that functionality. We can still pause and play as normal. We just have handling so at the end of the song, can we start at the beginning.
Very cool.
So, all right, with that, now we have a good deal of ground covered. We have our song editor now able to handle song data. It's able to display that data and allow the user to control the playback of that data. Now from here we need to start moving into some of the actual editing topics, but we'll address those here in the upcoming videos.
Okay.
So that is going to take care of this video.